Among the early members of the society were 6 men who had attended Liberty Hall Academy or one of its earlier incarnations, and several vigorous advocates of the young school, including General Washington himself and the celebrated Lighthouse Harry Lee, who would become the father of Robert E. Lee. Yet another advocate for the school was Major Alexander Stewart, who had donated 40 acres to Liberty Hall in 1776. He was later captured at the Battle of Guilford Courthouse in North Carolina. At the same battle was his son Archibald Stewart, an Augusta Academy alumnus who became president of the Phi Beta Kappa chapter at William and Mary, and who carried the society's seal into battle with him. In 1802, the Society of the Cincinnati ceded its treasury of approximately $25,000 to Washington College. That gift, as well as bequests from General Washington and jockey John Robinson, constituted the school's entire endowment at the time. The gift from the Society of the Cincinnati continues to support both this convocation and an endowed chair in the mathematics department. With the Society's gift also came some stipulations that the university continues to honor. One was that the college institute studies in fortifications and gunnery. Sure enough, such a course is still offered by the mathematics department. And I guess that's logical because they're technically funded by the Society of the Cincinnati Foundation. The course is called Military Engineering. It carries no credit and has no course number, but if you go home today and look in the 2009-10 course catalog, page 200, it indicates that, quote, for qualified students who may request it, a course in fortifications, gunnery, and ballistics will be offered. Of course, if anyone actually requests this course after today, I'm sure the registrar's office will not be very happy with me for pointing this out, not to mention whatever faculty member has to teach it. Recognition not only of the Society of the Cincinnati's generosity to Washington and Lee, but also of its support for our liberal arts mission has become quite suitably linked with today's celebration of the university's outstanding young scholars. We at Phi Beta Kappa continue to be deeply grateful to the Society of the Cincinnati. I would like to call upon our chapter secretary-treasurer, Phi Beta Kappa member Steve Desjardins, to announce the names of those recently elected to membership in our society. Dr. Desjardins will also bring to your attention some particularly noteworthy scholarly attainments of several additional students. Dr. Desjardins.
Thank you, Professor France. Last year, the Gamma of Virginia chapter of Phi Beta Kappa elected to membership as juniors 18 members of the class of 2010 and recognized them here in Lee Chapel. Hiba Asi, Natalie Ida Bennell, Whitney Renee Burns, William James Cooper, Josiah William Davis, James Christian Dick, Neville Lyons Fogarty, Stephanie Ann Marks, Joseph McDonald, Kristen Elizabeth Quinn, Holly Ratliff, Rachel Michelle Skanes, Dorothy Rebecca Todd, Sarah Josephine Trimble, Dorinka Trebuchek, Bena Shishiku, John Russum Weems, and John Thomas Wren Jr. And now for this year's initiates. As I read your name, please come up on the stage and face the audience, and remain on the stage until your classmates have all been recognized. And for the rest of us, please hold your applause until all the new initiates are on the stage. First, our initiates from the class of 2009 and 2010. We elect a handful of members from the just graduated class based on their final grades. This year we welcome 3 members of the class of 2009. Emily K. Deddens, Alexandra Mary Locking, and Jennifer Nicole Sanow. These members are now joined by the initiates from the class of 2010. Andrew Nicholas Asapimanwait, James Vernon Baird Jr., William Wallace Billington III in absentia, Catherine Page Boyles, Samuel Braska, Andrew Christopher Budzinski, Edward Callahill Burks III, Ian Childers, Emily Faye Coyle, Dinah Elizabeth Danford, Brian Ellis Devine, Joshua Alejandro Gonzalez, Charles Edward Griffin, Caroline Marion Hableson, Margaret Rose Harrington, Jessica Caitlin Camp, Meredith Dowd Mitchell, Benjamin Mooneyham, Anaria Nardone, Elliot O'Brien, Anthony James Oley Jr., Jock Flug, Brood Reedy, Thomas Rutherford Sellers, Victoria Maureen Stevens, Kimber Lauren Wiggs. Let's congratulate them. And now the members of the class of 2011. Their individual grade point averages place them in the top 5% of the junior class. Catherine Elizabeth Anderson, Christina Bratu, Bridget Mary Donovan, David James Dubin, Claire Mairead Elder, Taylor Garrett, Granville George in absentia, Robert S. George, Anna Marie Hermesman, Anatoly Kamenko in absentia, Michael Todd Kuntz, Gregory Matthew Kirkus, Mo Chung Pung, Hannah Elizabeth Muther, Susan Payton, Lauren Frances Sturdy, Victoria Ray Taylor, Frank Andrew Tessier, Jr., Melissa Beth Valentine, John David Walton, Jr. Finally, from time to time, our chapter elects honorary and alumni members as specified in our Constitution. An honorary member is defined as a person who is distinguished in letters, education, or public service. Following these specifications, this year we elected an individual who met those qualifications and then some. His contributions to academia as a scholar, a teacher, and now as an administrator are greatly appreciated by his colleagues and students. Please join me in congratulating our new honorary member, Robert A. Strong. Finally, I have the pleasure of announcing the winners of 2 other awards. First is the newly renamed Phi Beta Kappa J. Brown Goering Award. The award is named for a man who truly exemplifies Phi Beta Kappa at Washington and Lee, Dr. J. Brown Goering. Dr. Goering, a chemistry professor at Washington and Lee for 38 years, served as Secretary-Treasurer of the Gamma of Virginia chapter of Phi Beta Kappa for 22 of those years. We present this award to the sophomore who has achieved the highest academic average during his or her first 4 terms at Washington and Lee. I'd like this member of the class of 2012 to stand and receive our congratulations. Brooke L. Sutherland. Second is the Edward Lee Pinney Prize. The Student Affairs Committee gives it to an undergraduate or undergraduates who, in the words of the prize, demonstrate extraordinary commitment both to personal scholarship and to the nurturing of intellectual life at Washington and Lee. I'd like them to stand and receive our congratulations. Only one of them is here today, the other is sick. From the class of 2010 and initiates into last year's Phi Beta Kappa group, Natalie I. Bonnell and Baina M. Shishiku. And now I return the podium to Dr. Marcia France, President of the Washington Lee Chapter of Phi Beta Kappa. Professor France.
Thank you, Professor Desjardins. I would like to take a moment to share with you just a few observations with our newest members. Washington and Lee enjoys a national reputation for academic excellence. Assurance that this reputation will endure depends on both on those who teach and those who study here. For it is by our work's quality that the university will continue to be measured. You, the new members of Phi Beta Kappa, do well to understand the honor and the responsibility that are now yours. It has been and will continue to be our privilege to know you and to instruct you. By your accomplishments, you have earned our gratitude and highest commendation, and you have clearly exhibited your desire to embrace and uphold the love of learning, open-minded inquiry, lively debate, and free flow of information that stem from the liberal arts tradition. I now have the pleasure of introducing to you our speaker, Dr. Robert Wolke, who will deliver our keynote address. Dr. Wolke is Professor Emeritus of Chemistry at the University of Pittsburgh. He received his bachelor's degree in chemistry from the Polytechnic Institute of New York University and his Ph.D. in nuclear chemistry from Cornell University, where he was inducted into Phi Beta Kappa. Dr. Wolke was a postdoctoral research associate at the Enrico Fermi Institute of Nuclear Studies at the University of Chicago. During his long and productive career at Pittsburgh, Dr. Wolke was founder and director of the Warrett Laboratory of Nuclear Chemistry, founding director of the Office of Faculty Development, and served as an academic dean for the Semester at Sea program. In addition to his impressive publication record in nuclear chemistry, Dr. Wolke has also been a major voice in making chemistry accessible to the non-scientist. He was author of the Food 101 column for the Washington Post from 1998 to 2007, and a consulting editor for Cook's Illustrated magazine from 2001 to 2008. Dr. Wolke is the author of 6 books, 2 chemistry textbooks, 2 books on the science of food entitled What Einstein Told His Cook, Volumes 1 and 2, and 2 additional Einstein books on everyday science for lay people. The Einstein books have been translated into more than 20 different languages. 2 of these books were nominated by the James Beard Foundation as the best reference book of the year in which they were published. Dr. Wolke is the recipient of numerous awards, including the James Beard Foundation Journalism Award for Best Newspaper Food Column in 2000, the National Society of Newspaper Columnists Award for General Interest Columns in 2000, the Association of Food Journalists Award for Newspaper Columns in 2001 and 2002, and the American Chemical Society's Grady-Stack Award for Interpreting Chemistry to the Public in 2005. I first learned of Dr. Wolke's work when I began doing research for my Science of Cooking course. His books are informative and fun, with the perfect mixture of science and humor. My students and I have very much enjoyed reading these books. I am pleased to finally have a chance to meet Dr. Wolke and to welcome him to Washington and Lee. We are indeed privileged to have such a distinguished scholar, author, and journalist here with us today. Please welcome Dr. Robert Wolke.
Thank you. Professor France and everyone else I've met here made me feel very welcome at WNL. One of your alumni friends of mine told me how to say that. Did I say it right? WNL? Okay. In my 50 or more years in various universities as student, faculty member, everything else, I've never seen so many well-dressed undergraduates. Professor France introduced me as Professor Emeritus of Chemistry, and when I speak at non-academic gatherings, sometimes people don't know what the word emeritus means. So I analyzed the word for them. It's Latin, of course, and if you split it up into its syllables, E means out of, as in E pluribus unum, and meritus, of course, means value or worth. So right, kids, you're ahead of me. An emeritus professor is one who is no longer of any earthly use. I'm going to address my talk to the Phi Beta Kappa initiates, and anyone over 30 who wants to leave the room has my permission. But it's going to be about knowledge and education, and I want to tell you a little anecdote first, which will introduce the topic. Back in 1967, when my daughter was born in Pittsburgh, the Children's Hospital of Pittsburgh was the first hospital in the United States that had changed all of its records over to what we in this country call the metric system. And they were very, very proud of that fact. Well, my daughter needed a little minor surgery as an infant, and so at the age of 3 months, we bring her very timorously into the hospital for her surgery, and after they ask about the insurance, of course, then they ask what her religion is, and I said she hadn't decided yet, that three months old, mind you. And then they have to weigh the baby, of course, for various reasons. I handed the baby to a nurse, and she's weighing the baby, and just out of nervousness, I asked how much she weighs, not that I cared. And the nurse said, "Well, sir, I could tell you the number, but you wouldn't understand. It's in kilometers." That is a true story. It's a very long baby, of course. But that illustrates something. I'm going to harp on this poor nurse, who's probably retired by now, as an example of something I want to, the point I want to make. The title of my talk is "A Little Knowledge, ... and if somebody here will fill in the rest of the expression, is a dangerous thing. Okay. Little knowledge is a dangerous thing. Well, that comes from the 18th century. An English poet named Alexander Pope wrote this in a poem, except he said a little learning is a dangerous thing. And I think there's a big distinction between knowledge and learning. Knowledge is information that you accumulate, things that you didn't know before that you know now, of which the undergraduates here have had a lot of. But I contend that knowledge isn't learning until it has been followed by thinking. You get knowledge, but it is not learning until you have thought about it and put it into perspective and really made it your own information. Then you will have learned it. And in the case of the unfortunate nurse, we could be very charitable and say she just had a slip of the tongue. But another explanation is that she had the knowledge. They had taught her what all of these metric units are, but she hadn't learned it because she hadn't dwelled upon it and made it her own. And many of you, all of undergraduates, I think, may wonder at times why the heck we have exams in universities, okay? And regardless of what you may think, it's not just because all professors are sadists, not all of them anyway, but an exam forces you to think about the material. And it gives you this second dimension of thinking about the stuff and forcing you to do that. And that's what makes it learning, converts knowledge into learning. So I want to give you several examples in the outside world about how so many things that we hear or read about, things that we supposedly now know, are not learning until we apply the thought process to it. I'm going to say, think about it, maybe half a dozen times in this speech. That's the link to learning. Let's start with glass. What is glass? G-L-A-S-S. We see it everywhere, in mirrors and in windows and in keeps our beer from spilling all over the floor and improves our vision and so on. But what is glass? Surprisingly, chemists have debated what glass is for many years. You know that when glass is very, very hot, it becomes fluid and it flows and it can be shaped into all of things by glass blowing and so on. And then as it cools down, it gets thicker and thicker and thicker, gets to be a more viscous liquid until eventually it seems to turn into a solid. And the question always that baffled chemists, and they debated over, was, is it now a solid, or is it just a liquid that has been supercooled down to a liquid thickness, which is absolutely rigid? So when I was in school in prehistoric times, they told us that glass was a supercooled liquid. It was not a solid. And that belief lasted for quite a few decades. But the mystery was, if it's a fluid, a liquid, why doesn't it flow even very, 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 very slowly over a period of hundreds or thousands of years? And then somebody went to look at the window panes in churches that were built hundreds of years ago, and he noticed that the square glass panels in the window panes were thicker at the bottom. And everybody said, that's evidence that the glass over a period of hundreds of years has flowed down to the bottom of the pane. And everybody was quite happy then. But then some spoil sport, and scientists are inveterate spoil sports, looked at a lot more of those window panes, and there were almost as many, not as many, but almost as many in which the thick part of the pane was on the right or the left or at the top. But the preponderance was thicker at the bottom. Now, did that prove that the glass has flowed? Well, think about it. If you were a workman building a cathedral in the 18th century, and you had these squares of glass that you were supposed to put into the panes of a window, in those days, glass was not absolutely flat and perfect. We have very high high-tech ways of making absolutely flat panes of glass, but in those days, glass was very irregular. Now, if you were a workman putting this in a pane, and you saw this side has a thicker bottom, wouldn't you feel it's natural to put it in with the thickest edge down? Because that's the way we think of stability. So the fact that there are so many thick-bottomed panes of glass has nothing to do with the flowing of a supercooled liquid. It's just that that's what the workmen did. Now we know what glass is. It is not a supercooled liquid, but it's not a solid either. It is an intermediate condition, which is called, oddly enough, the glassy state of matter. So until somebody, chemists are brilliant in making up names for new phenomena. So until somebody did a lot of thinking about why these panes of glass were thicker at the bottom, it wasn't learning. It was just actually a presumption. Okay, let's go to something very different. Let's go to baking a pie. As Dr. France said, I've written about food quite a bit. I am not a baker, but I know that when you mix the dough to bake a pie, and you want to have a crisp, flaky crust instead of a muddy one, when you mix the butter or lard or Crisco, whatever it is, in with the flour, you cut it up into pieces. You don't blend it in thoroughly. And while you're rolling out the dough, you do not want that fat to melt. If it melts, I don't want to go into the mechanisms, but if it melts, you'll get a soggy pie crust. But if you keep that butter or lard, whatever, from melting, you will have a flaky pie crust. So what do professional bakers do? In their bakery, they have a big slab of marble, like a marble countertop. And they roll out their dough on that slab of marble. Why did they do it? Everybody knows. Marble is colder, and the heat from the friction of rolling it does not make the butter melt because the marble is cold. Well, everybody knows that too, but think about it. Touch a marble slab. It does feel cold, doesn't it? A marble floor, if you're lucky enough to have one in your bathroom, feels cold on your bare feet. So, marble, is it really colder? Okay, let's think about it. If you take this bottle of beer I mentioned before out of the refrigerator, it's nice and cold, and you open it up. I know you undergraduates would know what that is. Beer is a beverage brewed from barley and hops and things like that. But you take it out and have a sip and then leave it on the counter or on the table or whatever. What happens to it? Eventually, it warms up. Again, make yourself a cup of hot coffee, take a sip, leave it out. What happens to it? It cools down. So anything that is warmer or colder than its surroundings will absolutely naturally get cooler or warmer until it comes to the prevailing temperature of the room. That's a fundamental law of how heat moves. It always moves from a higher temperature to a lower temperature. So that slab of marble cannot be just sitting there day after day, week after week, month after month, just being colder than everything else around it. That would violate all kinds of laws of thermodynamics. So what's behind it? Ask any baker and you say, oh, it works. The fat does not melt as it would if I did it on this wooden counter. Well, when we think about it, we realize that why it works. It works not because the marble is colder. It works because marble is a better conductor of heat than things like wood. And what it does is conduct away whatever heat is produced by the friction of rolling the dough. So it's a heat conductor, Nothing surprising about that. Metals are marvelous heat conductors. All substances conduct heat to various degrees. The marble is not sitting there defiantly being colder than anything else. Does everyone know the 5-second rule? I thought so. I thought so. For those who don't, it says that if you drop your food on the floor, you must pick it up within 5 seconds, and it's okay to eat. If it's on the floor longer than 5 seconds, it's dirty, you better throw it away, okay? Now, can I see the hands of anyone who believes that? I know, I've intimidated you, and you won't admit to it. But it's been around for a long time. A lot of people believe it, and my watch has stopped. Okay. Okay. People have tested this. I mean, scientists have tested it. You know the television show Mythbusters? They have tested it. Even some distinguished food scientists have tested it. A man named Harold McGee, who wrote a marvelous food science book, tested it and did the experiment and wrote about it for the New York Times, and they were all utterly stupid and misguided. They all got inconclusive results, as I could have told them, because I had thought about it. And if you think about it, what does the germ contamination of a piece of food on the floor of a room depend on? It doesn't depend on how long it has been in contact with the food. It's not as if microbes have little tiny pogo sticks or trampolines and they're just waiting to jump on your food and contaminate it. The most advanced microscopic studies of bacteria have yet to find a pogo stick to scale with the bacteria. No, they don't jump on your food. How do germs get on your food? The germs reside in the dirt. So what it depends on is how dirty the floor is, how sticky your food is, and dirt sticks to sticky things, period. And if the dirt sticks to a peanut butter and jelly sandwich, it's there. And it's there 10 minutes from now and 2 weeks from now and so on. So it's, these people didn't just take knowledge, because the knowledge was waiting there to be discovered, but they didn't convert it into learning until they thought about it. And all of these experiments were just wastes of time. Since you now know what beer is, let's switch to carbonated beverages. I read somewhere some time ago that in the United States there are 12 billion gallons of carbonated soft drinks consumed every year, and 6 billion gallons of beer. And that's only at W&L, of course, but that's an awful lot of carbon dioxide gas. And I started thinking, what happens to all of that carbon dioxide gas? We imbibe it, and eventually we get rid of it by respiration and eructation, which means belching. And so it goes out into the environment. And all of this carbon dioxide is, of course, a greenhouse gas. And I wondered, is that a significant contribution to the greenhouse effect and global warming? All of this belched carbon dioxide. Now that you can think about, and I did think about, but that's not enough to make it learning and tell me the answer. because thinking about it won't answer it. You have to do an experiment, you have to do a calculation, you have to find out how much CO2 are we talking about. And so I did those calculations. And I found out that the beer alone puts 200,000 tons of carbon dioxide into the atmosphere per year. Now that's not just here, that's the whole country this time. Whereas compared with the amount of carbon dioxide put into the atmosphere by automobiles, by burning gasoline, that is 540 grams, oh wait a minute, a bottle of beer, single bottle of beer contains 22 grams of carbon dioxide, whereas an automobile puts out 540 grams of carbon dioxide per mile driven. So as I expected, carbon dioxide is not beer is not warming the atmosphere compared with driving automobiles and burning petroleum fuels. You get 24 times as much CO2 per mile in a car than you get from a bottle of beer. So for every mile less you drive, you're entitled to 24 bottles of beer. But not at the same time. Okay. One more. I'm going to add a qualification. How's my time? A qualification to my equation: learning equals knowledge plus thinking. Remember that. L equals N plus T. Okay? Why are you snickering? Is it? L equals N plus T. Learning equals knowledge plus thinking. But I'm going to add something to it now to take the learning into an education, a useful education of putting this knowledge and learning to use in your lives after you get out of school. And you should never get out of school. You've heard this before, never stop learning. I mean, as long as we're breathing, we got to keep learning. That's the fate and duty of our species. If your refrigerator is smelly, what do? Clean it. There's a practical person, yes. But in order to keep your refrigerator from getting smelly, what do you put in it? Baking soda. That little yellow box of Arm & Hammer baking soda, you tear off the top, put it in your refrigerator, and it will keep it fresh smelling. According to Arm & Hammer. That is one of the biggest scams ever promoted on the American populace and probably worldwide, as far as I know. And now they are saying, they have been for some time, not just in the refrigerator, buy another box and put it in your freezer. So I did a calculation. If every house, and also replace it every 3 months. Okay? Because, of course, it gets warm out by sucking up all of those smelly molecules. If every household in the United States with a refrigerator has one in the refrigerator and one in the freezer and is replaced every 3 months, Arm & Hammer sells 420,000 tons of bicarbonate of soda per year, baking soda per year. It's a great, great scam. But I did some thinking about it, and I'm a skeptic anyway. What conceivable mechanism can there be that a box of sodium bicarbonate sucks up smelly molecules from the 20,000 cubic inches in your refrigerator? No mechanism that I could think of. And it doesn't. Now, they have improved the product. If you look in the supermarket, you'll see that the boxes of baking soda now have open sides, filter paper, that are permeable to air. And so the smelly molecules in your refrigerator must enter on this side, pass through the baking soda, and come out the other side. Now, any smelly molecule knows exactly what it should do, and they even call it a flow-through box. It's idiotic. So by being very devious, I got from Arm & Hammer the report of the, quote, independent laboratory, unquote, that proved that it does suck up odors. Because you know what an independent laboratory is. It's a company that gets a lot of money for giving the sponsor the answer it wants, okay? If I ever wrote and published a scientific paper based on evidence that weak, I would have been fired from my jobs at universities long ago. It doesn't work. They cannot prove it works. The last thing I want to put into that equation of L equals M plus T is I want to add an S to the end of that, and that is skepticism. We have to be skeptical of absolutely everything. You've got some knowledge, you've thought about it enough to get good grades on the tests, then you come out of school, and what you have to have from your education is not all this knowledge. You know you're not going to remember all that stuff. But skepticism. You have been shaped into a skeptical, educated person. And especially these days, when we are flooded with so much nonsense, so much deliberately misleading knowledge and misinformation on the internet and on all of the electronic things. Everybody's trying to sell you something, to convince you of something, to scare you about something, all of these urban legends on the internet. Skepticism, skepticism, skepticism. Thinking about it may or may not be enough, but the moral of this whole thing I'd like to leave you with is many things are simply not what they appear to be, and it's up to you to do the thinking and be skeptical of it and come to your own conclusions. Come to your own conclusions. Be skeptical of everything, including everything I've said up till now. Thank you.
Yeah, see, you guys missed this part.
I'm sorry, I misspelled knowledge. I put a K in there.
Thank you, Dr. Wolke. We're very pleased that you were able to be with us here today. For those of you who would like to speak with Dr. Wolke, he will be available from 3 to 4 this afternoon in the Commons Atrium. I would like to thank all of you who have joined us here to honor our initiates. Before we adjourn, I would like to add a special word of thanks to Secretary-Treasurer Steve Desjardins, previous Secretary-Treasurer Julie Campbell, Administrative Assistants Jennifer Ashworth and Barbara Higgins, and Debbie Hattersley in the Registrar's Office. The 5 of them have done a tremendous amount of work to make this day possible. We are grateful for their assistance. Thank you very much for coming. This Phi Beta Kappa Society of the Cincinnati Convocation is now concluded.